Hello viewers, welcome to Karnataka PGCET Awareness Program. I, Ms. Vijayalakshmi Patel, Assistant Professor at Department of Master of Computer Application, KLS Kokte Institute of Technology, Belagavi, would like to introduce operating system concepts. Before I start my lecture, let me take this opportunity to introduce to you our accomplishments. We are A+ accredited by NAC. We are also in the top ranking of the technological schools like DataQuest 2020. Among the private engineering colleges, we are at the top 24th rank. We are also ranked under NIRF. What may be of interest for you is that we have a tie-up with Shibura Institute of Technology, Japan for a student exchange program. Under this student exchange program, we send our best students to Japan to work under their research projects. To start with, let's see the syllabus of operating system for PGCET. The syllabus contains evolution of operating systems, types of operating systems, functions of an operating system, and modern operating systems. So what is an operating system? An operating system is a program that manages a computer hardware. It acts as an intermediary between the computer user and the computer hardware. The operating system is the only program that is always running on the system. And this operating system that is running on the system is the core of the operating system, the heart of the operating system, which we call it as kernel. Operating system evolution starts from 1955 with a few operating systems being introduced. Then later in 70s came the most important operating system, which was the Unix operating system. This is a command-based operating system where all instructions to the system are given through a command prompt. It is a text-based and not a graphical interface. Next came in 75's DOS operating system, which is also called as disk operating system. This disk operating system that was also introduced by Microsoft as Microsoft Disk Operating System, MS-DOS. At the same time, there was another operating system that came up, which was the Berkeley Software Distribution, which is BSD, which is recently the BSD version is what is available is FreeBSD. This is an open source again, and it is also based on Unix. There were also other operating systems that were introduced, which were based on Unix, like POSIX and Mac operating system. Mac operating system is basically a Macintosh operating system, which is a proprietary operating system. Now, proprietary operating system means an operating system that runs only on certain hardware devices. They are basically of the same company that the software manufacturer is. So the hardware device manufacturer has his own software, and the software runs only on those hardwares and not on all hardwares. Like your Windows operating systems run on all hardware. So Windows 3.0, Windows 3.1 are all these which are derived from MS-DOS, and these MS-DOS operating systems, which were derived from MS-DOS operating systems, were the graphical interface based operating systems like your WinNT. WinNT is nothing but the Windows network operating system. Then we have Win 2000. Then we had Windows Server. We have XP, Windows 2003. Then Windows 2007, 2008, and recently Windows 10. Right now, the version that is running in the market is Windows 2010. Now let's come back to Unix operating system. So from Unix operating system, they were derived POSIX operating system and Mac operating system. POSIX is a generic operating system. So this operating system can be implemented or used on any hardware, whereas a Mac was only on an Apple company based operating system, which was running only, which would be executed, installed only on a Apple or a Macintosh devices. From Unix in 95, a Linux operating system also was derived. This Linux operating system is based on Unix operating system, but it is a GUI based operating system. Apart from Unix, there was Solaris also introduced. Solaris also is a proprietary operating system. It is not an open source operating system. So the company that manufactures this operating system manufactures it for their devices. So this is basically the evolution of operating systems. Mac operating systems have seen various versions. Then you can also go and check out these version names on the internet. We have Tiger, Leopard, Lion. All these are various versions of the operating system of Mac. Types of operating system. We have batch processing, punch card, then we have multiprocessing, multi-user or time-sharing systems, and real-time systems. Batch operating system. In a batch operating system, programmers create their programs as jobs and submit these jobs to an operator. The operator then sorts these jobs based on similar kind of jobs and makes these jobs into a group of batch. So a batch contains all programs that are of similar type, and he fits these programs into the CPU or the system, and that all the programs are executed one after the other in a batch. The output of such programs are also taken in a group. These outputs are then submitted to the programmers who submitted the programs for the execution. An example of such a system is IBM 1401 system. The 1401 system contains a 1401 processing unit, 1402 card reader, and a 1403 printer. Now the processing unit is the one which processes the instructions and executes the instructions. The card reader is an input device wherein you put in the wherein you write your programs on the cards and submit it for the system to execute it. And 1403 printer is the output device where you get the output of the programs or errors, if any, in the programs, where the users or the programmers would have to correct them and submit it again for execution. So this is what is a batch processing system. The punching cards. A punch card or a punched card is a piece of shift paper, sift paper that can be used to contain digital data represented by the presence or absence of an hole. So if the hole is present, that means the data is present. If the hole is not present, it means that the data is absent. Or it can be indicated as zeros and ones, as we have the latest operating all the systems that work on zeros and ones. So a hole indicates that one is present, and a zero indicates no hole indicates a zero value. So 0 and 1 is then converted into a program, and it is into a codes, and codes is converted into a program, is executed as a program. So in this way, we had punched cards that were used for programming, and the most famous one is the IBM 12 rows 80 column punched card format, which was dominating in those days. Multiprocessor system, on the other hand, is a system wherein you have multiple CPUs. So a single CPU is, the olden days had a single CPU wherein it had a single Pentium 4 processor or a Pentium 3 processor. But nowadays we have processors like octa-core, quad-core. Quad-core means 4 CPUs and octa-core means 8 CPUs in the system. So these CPUs work together to accomplish a task. The way these CPUs are connected and they are coordinated and controlled, that they make up a symmetric multiprocessing or a asymmetric multiprocessing. If multiprocessing systems are connected and made to work together, like here in this example, 4 of the first multiprocessors are connected to another 4 multiprocessors. So this kind of a connected system of symmetric processing is called as clustered systems. So what is a multiprocessing system? A multiprocessing operating system is a one which has 2 or more central processing units, and its function is to work or to execute a job on various CPUs simultaneously. So it divides the job into small tasks, and each of these tasks is distributed among all the CPUs that are present in the system. So what is the difference between a multiprocessor system and a single processing system? In a multiprocessing system, the OS can execute more than one program at a time. So it executes more than one program. So one program can be given to one CPU and another program can be given to another CPU. So in that way, if there are quad-core processor, then 4 programs can be executed simultaneously. A multiprocessor system divides the entire job into subtasks and then assigns these subtasks to different CPUs in the system. To do this, it requires a distinct communication architecture which is capable of maintaining or it has a mechanism for the processor to interact with each other. Because if they don't interact with each other, how will they coordinate and execute the task that is at hand? So they need to coordinate and accomplish the task that is given to it. A multiprocessor system basically relies on parallel processing. So what is parallel processing? Parallel processing means a job is divided into subtasks and given to multiple CPUs, and hence there is simultaneously a single task is having subtasks being executed on multiple systems, so it is called as parallel processing. Parallelly, the program execution is going on. So each processor involved in a task must be able to inform others about how its task is processing. And for this, the processors access the shared memory. So a symmetric multiprocessor is also called as a tightly coupled multiprocessing system. It's called tightly coupled because all the CPUs work together for a single task. They all coordinate and work together. Hence they are called as tightly coupled. They are communicating with each other and they are doing the a single task can also be executed by multiple processes. So it is called as a tightly coupled multiprocessing system. For this, the multiprocessing system should have a processor symmetry. The processor symmetry means that the OS should treat all its processors equally. Asymmetric, on the other hand, means that it has again multiple CPUs, but these CPUs do not coordinate and work together as equal processors. Here, the processors are either working independent of each other or there is a master-slave relation between the processors. So in this case, if there is a master-slave relation between the CPUs, then there will be the master, a single CPU will be a master CPU and it will take all the instructions from the operating system and it will assign the job to each of the other slave processors. So the master processor is controlling the entire system. An asymmetric multiprocessing system where only one option is available, it was the only one option that was available before a symmetric multiprocessing was evolved. And it is the it was the cheaper option as compared to a symmetric multiprocessing system. The difference between asymmetric and symmetric multiprocessing on these following keys are that if CPU is considered, all processes are not at equal precedence in an asymmetric multiprocessing because there is a master-slave relation between the CPUs, whereas in symmetric multiprocessing, all the CPUs are having the same precedence. They are all equal. OS task. Who executes the operating system tasks? In asymmetric multiprocessing, obviously the master processor only executes the OS tasks. and master processor will inform the other CPUs what they have to do. Whereas in symmetric multiprocessing, OS tasks can be executed by any processor because all processors are considered equal by the OS. Next is communication overhead. Yes, in asymmetric multiprocessing, there is no communication overhead because all CPUs are equally are all working in a master-slave relation, and hence they do not need to communicate with each other. If they were, as each of them are executing their own task and they are not dependent on each other. Whereas in symmetric multiprocessing, all the CPUs are coordinating and executing certain tasks. Hence, they need to communicate with each other, and they need to communicate with each other when they are accessing the shared memory. So if one CPU is accessing the shared memory, the others should not access at the same time. So there needs a communication between them. Process scheduling. So in what is a process scheduling? A process scheduling is which job has to be executed next has to be decided by the system. So for this, the master-slave relationship in asymmetric multiprocessing, obviously the master decides which job has to be executed and which CPU who is going to execute that job is decided by master. So in asymmetric, master decides. In symmetric multiprocessing, the processes are put in a queue and they are taken out first in, first out. So in this order, there is other queues also, not only the first in, first out queue. It can be a priority queue as well, wherein the priority processes are executed first and then the non-priority processes are executed. So that is how a process scheduling takes place in asymmetric and symmetric multiprocessing. If you consider the cost of an asymmetric multiprocessing is cheaper as compared to a symmetric multiprocessing system. And in terms of design complexity, asymmetric multiprocessor is simpler because it does not contain any communication overheads or it does not have any other complications. Whereas in symmetric multiprocessing, because there is communication between CPUs required, hence we need to have, there is a complex design algorithm in symmetric multiprocessing. Use multi-user and time-sharing systems. What is a multi-user system? A multi-user system is a system wherein multiple users can log into the same system and use the system simultaneously. So such kind of a system can also be time-sharing system. Means every user will be given a time slice of in which his or her work will be executed. So for example, here there are 5 terminals. So these terminals are computers. They are not having the CPU. They are only having the required devices that are required to connect to the central computer. So they communicate with the central, whatever execution has to be done is done on the central computer, and the terminals communicate with the central computer for all its execution requirements. Not only the execution requirements, it is also the resources. In such a system, resources are always shared. So, multi-user or a time-sharing system, for effective usage of the CPU time, many users are connected to one or more computers from a time-sharing environment. And in this environment, the central computer performs the following task. It does controls the shared resources, manages shared data and printing jobs, and it does the processing as well. In a real-time operating system, which is also called as RTOS short form for real-time operating system, these work on real-time constraints based on power, time, and efficient usage of memory. So you have seen a lot of real-time systems around yourself, like your microwave, your airplane, which is autopilot, then you have printers, then you have cameras, securities, traffic management, lights. All these are real-time systems. So most of them are embedded systems and they have a real time constraints, and it is achieved using real-time systems. So you need to have uh, the timing based execution of task, and this is managed by operating system. And such kind of a real-time operating systems can be of two types. One is hard real-time system and another is soft real-time system. The difference between hard real-time system and soft real-time system is that in hard real-time system, the time constraints are very rigid. You have to be following the time constraints compulsorily. In a soft real-time system, the timings are not so very restricted. There is some flexibility in the time restrictions. What are the functions of an operating system? So operating system has 8 functions. First one is memory management. So it has to take care of the main memory. So main memory is nothing but the RAM, wherein your programs that need to be executed are brought into the main memory, because only from the main memory the CPU can execute your programs. So managing these memory resource is the task of a main memory management. Next, you have device management. So various devices are connected to a system like your keyboard, mouse, monitor, and not only that, all the other devices that are there on the system like your hard disk and all that, they are all managed by your operating system. Taken care that their communication between them is established, and the tasks that is required to be executed by these devices are all taken care by operating system. Next one is process management. Process management means there are multiple jobs are put into the main memory so that they can be executed simultaneously. So for this, a lot of activities take place at the background. We feel that multiple programs are executed simultaneously, but they are not executing simultaneously. They are executing one after the other, and this task is managed by operating system. So we don't understand how it is managing the process programs, but it manages all the programs as though they are all running simultaneously. But actually, CPU can execute only one program at a time. Next is security. Operating system has to take care of the security in terms of, like, for example, multiple users are there on the system, and each of these users are having their own privileges of executing, reading, writing of data. So all that is taken care by operating system. It not only takes care of the security in terms of the users, but it also takes care of the security in terms of programs. One program should not uh, corrupt another program, and it should also not corrupt the operating system. So that security is taken care by operating system. Next is error detection. So if there is a program that is working wrongly, then it is a task of the operating system to identify that and to take care what has to be done with such a program, whether it has to be blocked, or whether it has to be suspended, or whether it has to be exited. So all that task is done by the operating system. It also has to give proper message to the user as to what error it has occurred. So all that error detection and correction or handling of situations is done by operating system. Next is coordination between software and user. So whatever commands that we give to the system or to the software, to any of the applications we use, they are all commands that are indirectly given to the operating system. Supposing now we want to print a file. So that printing of a file is an instruction that is given to, for example, we are using a Word document and we need to print a Word document. Then I am saying print command on the Word file, but actually it is giving an instruction to the operating system. The software gives an instruction to the operating system that use the printer device and print this information. So the operating system has to take care of all the tasks that is behind it. Next is job accounting. Job accounting is, there are various programs executing on the system. So all these programs in accounting has to be done. How much memory it is using, how much resources it is using, and how it is affecting the system. All that information has to be recorded for maintenance purpose and for the operating system understanding, as well as handling of the programs and problems that can arise due to these programs. So all that accounting is done by operating system. Next is file management. So we have different kinds of files, directories on our system, on our secondary storage device like our hard disk, pen drive, etc. So all that is managed by operating system, like opening the file, closing the file, reading the file, writing to the file. So all that is the task that runs behind this commands is taken care by operating system. So those are the various operations that are taken care by the operating system. Understand the modern operating system. So we have MS-DOS operating system, MS Windows, Microsoft Windows operating system, which is a GUI based operating system, and latest version is the Windows 10. Next you have Ubuntu. Ubuntu is based on Unix operating system, Linux operating system. It's a GUI based and it's an open source operating system. Open source operating system means it's an operating system where anybody can write in their part of code and they can make it for themselves. So that is what is an open source. Mac operating system is also a Unix based operating system, but it is not a open based, or it is not generic operating system. Generic means it can be used on any system. Windows is a generic operating system. It can be installed on any system which meets the Windows operating system requirements. Like for example, how much memory it requires, how much processing speed that system should be. If it matches that requirements, you can install the Windows operating system on such systems and you can use it. Whereas Apple Macintosh operating system are built for proprietary based. Proprietary based means these operating systems will run only on their specific devices, not on all devices. Fedora is another operating system, whereas it is Linux based and it is also generic. You can install it on any devices you want. Solaris is also a proprietary operating system. FreeBSD is a generic operating system. It is also Unix based operating system. Chrome OS is an operating system which is recently introduced by Google, and it's not so famous still. It's not being used much, but it is recent introduction. We have similarly CentOS, Debian, and Deepin. All these are latest and not so used, but the most popular ones are the first four, which are MS Windows, then Ubuntu, Mac OS, Fedora, Solaris. Up to Fedora is what is the most famous ones that are used in the market nowadays. Thank you for listening and your patience hearing. For any queries, you feel free to email me at my email ID bcpatil@git.edu. We are also coming up with a mock PGCET exam, so you all can attend that and you all can also understand. There are various other videos also on PGCET awareness program for the other concepts. You all can please view them also. Thank you.